Right. So it was night, and I was on my way home from a basketball practice. The cool air brushed against my skin, and I was exhausted. But then something happened. I looked up, and the sky caught my attention. I couldn't believe what just happened. I stood still, and I was unable to look away, and I was completely mesmerized by the vastness above me. But then, suddenly, a question struck inside my head. What if, what if we live in the simulations? Why is there stars and a planet in this world? What is a star? How, where are we going in this world? And how do scientists predict that there are millions of galaxies? Well, if that's true, how is there in a trillion of planets we are the only living creatures, right? Well, I couldn't stop. My mind was spinning, jumping from one questions to another questions, until a, a deepest question struck me in. What if we aren't alone? And in that moment, I realized something. This what if game isn't just about a game that my mind was playing. This was the essence of curiosity. This is the reason we explore, we question, and we reach beyond what we know. So, today, I want to invite you to play the same what if game with me. Because the questions and the answer to these questions could change everything. Now, let me leave you with one what if questions. What if aliens exist? Could they be friendly? Could they share the technology with us that makes our wildest science fiction dream come true? Could they help us cure disease, travel through time, or start a new life on another planet? Or could it be the opposite? What if we are like a primitive species compared to them? What if we are like ants in their eyes, so insignificant that they don't even notice us? Or worse, what if they do? Well, you see, this what if, what if game really fascinated me. And it led me down to a rabbit hole of questions that humanity has asked for centuries. And to answer these questions, we, humanity, has the right tools and ways to solve it, known as the Drake equations. Wait, did I just say Drake equations? Did you mean this guy right here created an equations? No, 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 no. Silly me, it's not this Drake. It's this Drake right here, okay? So his name is Frank Drake. He is a famous astronomer and astrophysicist that proposed an equations as an attempt to calculate the possibility of a detectable intelligent civilizations in 1961. And the equations looks like this. N is equals to R times Fp times Ne, and so on. And now let's solve it step by step, right? First, what do we have? We have R, capital R. Well, R is known as the rate of star formation each year. This means that how many stars formed in each year. And based on the observation data from the Kepler and also the James Webb telescope, they suggest that nearly 1.5 until 3 stars forms each year. And let's take the middle point of the data, which is around 2. And let's put it in equations. We have 2 in equations. Next, what do we have? We have Fp. And what is Fp? Fp is a fraction of stars that have planets, meaning that all of those stars, do they have planets? Well, the answer to these questions is known as the data from the Gaia missions and also the NASA. They has a conclusions that almost every star has at least one planet, meaning that Fp is equals to 1. Next, let's put it in equations. What do we have? We have Ne. What is Ne? Well, Ne is the number of planets that stars could support life in the stars, right? So basically, in those in those planets, how many how many planets that could support life? So basically, what is the number, right? And based on the based on the data that we have, it could be around 20 until 50%. And some argue between zero point 0.2 until zero point 0.9. Let's just use the middle number. That's around 6, 7. No, I'm just kidding. It's zero point 0.5. Yeah. Next, what do we have? We have fraction of R. Fr is the fractions of habitable planet that could develop life. So basically, those fractions of planets that could support life, could they have life in it? I mean, could species actually live in this planet, right? And based on our Earth data, we have a number which is about 0.3. Next, we have fraction of I, which is the fraction of those civilizations that could develop an intelligence. Well, this is very uncertain factors because intelligence is very rare, right? Well, in our Earth, in our planet, we have billions of species, but only one species that could develop intelligence, which is us, humans. And so there's a reasonable number, which is about 1%. And then we put around 0.01 in the equations. Next, what do we have? We have FC, which is the fractions of the civilization that develop a detectable communication technology. So in Earth history, humans has developed around 100 years ago communication technology, which is radio. And for if there's another species that has lived outside of this world, but they don't have a radio technology of a communication technology, how can we reach out to them, right? So there's a lot of numbers, and scientists argue it's between 10% until 20%. But we will use 0.1, which is 10%. And last but not least, we have capital L, which is the biggest factor in the Drake equation. L, which is the lifespans of a civilizations. Well, this number could argue between 100 until 1 million years, right? Well, because it depends on the civilizations. But reasonable estimates, they suggest that the number it could be between 100,000 until 200,000 years. So we will use 100,000 years. So now, let's calculate the number. N is equals to 1 times 2 times 0.5 times 0.01 times 0.3 times 0.1 times 100,000 and equals to N equals to 30. But what does that mean? Well, 30, known as the 30 intelligent civilizations in our galaxy. Wait. So do you tell me that there's around 30 intelligent civilizations in our galaxy? Well, even if there's dozens or even hundreds of intelligent civilizations in our galaxy, but why haven't we found any? Well, the answer to these questions is known as the Fermi paradox. It is a paradox that suggests several possibilities, such as maybe advanced civilization destroy themselves before they can communicate. And maybe the universe is just too fast for signals to reach us. And so, let me leave you with the questions. Why does this matter to you? Well, because this is the biggest mystery of all time. And we are the first generation in history that has the right tools to solve it. And right now, humans has discovered new planets, searching for alien signals and even sending their own messages into space. But maybe the real question is not about is there aliens, but the real question is will we last long enough to find them? I mean, look at our own civilizations. We have a great technology, but yet we'll still fight wars, pollute our planets, and even struggle to survive. Well, ladies and gentlemen, the biggest factor in the Drake equation is the L, capital L, which is the lifespans of a civilizations. So, in order for us, if we want to find aliens searching for new civilizations out there, we need to make sure that our own civilizations last long enough. So, what does that mean? So, it means that we need to protect our planet. We need to invest in science and even dreaming bigger than ever before. So, let me leave you with one final what if questions. What if we are the aliens? What if one day humanity becomes an interstellar civilization? Or what if in 100 years from now we are the one who exploring planets, searching for new species and make them believe and look up in the sky and ask, what if we aren't alone? Well, maybe the answer to the Drake equation isn't just about finding aliens. Maybe it's about becoming them. Thank you. That's all from me. See you next time.